All right, 28F, you said? 28F was, there it is. All right, so 28 was asking about various days of the year, and then it asked, it told you in the top directions for number 28 to assume. Now I just said assume equally likely, so let me look and say what it said we were assuming is equally likely. So assume each birthday is equally likely, and if we're excluding leap years. Then Part F said, do you think it's appropriate to use the methods of classical probability to compute the probability that a person is born in December? So, this would be a no. The reason why is because if we're picking out a specific month, then each month, because there aren't the same number of days in every month, that means that each month does not have the same probability. So the months themselves are not equally likely. Each day of the year is equally likely, but here in Part F, it's referring to the specific month. So December happens to have 31 days. It's going to be more likely to have a birthday in December than, say, in February, for instance. So classical probability assumes equally likely, which is not the case here. 42. Let's see. 42 was the one where it had given you a sample space. So let me put that up so we can look at that as we talk about it. So this is the sample space. And what it says it's describing is 6 possible assignments of probability for tossing a coin twice. So assignment A is saying heads, 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 tails, tails, heads, tails, tails, that each of those was 1/4. B is saying 0, 0, 0, 1. So it's giving the assigned probability in 6 different cases of each of those items. Number 42 asked which assignment would be used if tails is twice as likely to occur as heads. So if tails is twice as likely, then the heads should be the smallest and the tails should be the largest probability. So using that, the only choice, it doesn't really matter what the numbers are. It just matters that heads is the smallest and tails is the largest, which would be assignment F. Eventually, we'll talk about why the numbers are the numbers, but in this case, we just need to know which one to choose. 38E, we graphed. That one is, I think it's a scatter plot, but let me look at yes, it's a scatter plot. So graph scatter plot after you've uploaded the data, and then it tells you, so here are the directions for it. So it says graph the proportion of days the light was red against the number of days. And it says number of days horizontal axis. So select the day number 1 through whatever. That column should be your x-axis on the scatter plot. And then the aggregate proportion should be your y. And it should spit it out for you once you type in to label your axes and whatnot. What is the estimate of the probability of the light being red when you reach the intersection? So this isn't talking about a specific day. It's talking about overall, which means you need to take the table that's in your StatCrunch, go all the way to the bottom, and the answer is going to be the very last aggregate proportion number. So basically, very bottom right of the table.
For 30, like A, when doing the whole genotypes, lining it up, would it be 3 outcomes or 4?
3.
Okay.
So capital S, small s, and then small s, small s. It just happens that, big S, small s would be more likely than the other two.
And number 10, what does that, I didn't understand the question.
Okay. Let's look. Number 10. I didn't do a very good job of writing out enough for me to understand what the question was on my own paper. So I'll just read you the directions first. So number 10 says, in 7-card stud poker, a player is dealt 7 cards. The probability that the player is dealt 2 cards of the same value and 5 cards of a different value so that the player has a pair is 0.44. So that is just telling you probability of being dealt a single pair is 0.44. Then it says, explain what the probability means. If you play 7-card stud 100 times, will you be dealt a pair exactly 44 times? Why or why not? So explain what the probability means. A probability of 0.44 means that the expected value, the theoretical probability, is 44 out of every 100 would be a hand with a pair. What number 10 is trying to get after is that the second answer is no. Just because you play exactly 100 times doesn't mean that you're going to end up with exactly 44 of those times being a time where you're dealt a pair. That's because if you are actually playing the game 100 times, that's empirical probability, right? So you're actually recording the values, and empirical probability does not mean, is not always going to be exactly the same as your theoretical probability. Now, long term, like if we, played 10,000 hands of poker, we would expect the aggregate proportion to be about 0.44, but it doesn't mean that exactly 44 out of 100 will always turn out that way. Does that make sense?
Yeah.
What else, Delina?
So in 34 and some other questions, it asked if the probability was unusual. So is there a certain number?
Yes. So if it asks if it's unusual, what we wrote in the notes is the boundary level is 0.05. So if the probability is smaller than 0.05, then we would say yes, it's unusual. If it's greater, then we would say no.
What's over number 16?
16 If a basketball player shoots 3 free throws, describe the sample space of possible outcomes using S for made and F for missed. So you need to choose some sort of systematic approach to list them, but they're shooting 3 free throws, so the combinations should all have 3 letters, right? So made, 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 missed, made, missed, made. That's what you are listing. You should end up, if you want to double check your total number, you should end up with 8 different possibilities in the sample space. So just make sure that you use some kind of system for interchanging the letters so that you don't miss one. Hold on. 34A. 34A gives you the table with age and number of multiple births for women aged 15 to 54. A asks you to construct a probability model. So this is exactly like what we did in example 2A in the notes. So you're going to recopy the same. So here is the original table. So you're going to recopy this entire column, but instead of the number of multiple births, you now have to convert each of these to a probability. So you need to add all of these up. To check your work on that, I got that the total was 3,917. So you have to divide each of those to get your decimal probability for each. So you should have a decimal for each age group representing the probability that someone in that age group has multiple births, 3 or more babies. 18. According to the American Veterinary Medical Association, the proportion of households owning a dog is 0.372. What is the probability that a randomly selected household owns a dog? Same as what was given. Because if we're randomly selecting, then we would expect that the population proportion should match the sample.
This is just like a general question. Would you prefer decimals or like fractions?
It doesn't matter unless the directions specifically tell you how to list it. It doesn't matter to me. Just make sure that if you are listing it as a fraction, that the fraction is in simplest form. So make sure it's reduced if you're using a fraction. If it does not specify, then it really does not matter. It's just your preference. Hello?
Can you go by 26B?
26B. So 26 was talking about the police complaints in the Chicago Tribune. It said they analyzed 17,713 complaints. Part B said, if I can get it to show Part B, of the 7,296 complaints with an affidavit. So again, this original number is the total number of complaints. In Part B, it gives us the number of complaints with an affidavit. 794 were found to be legitimate. What is the probability that a complaint with an affidavit is found to be legitimate? So if we are looking at calculating the probability here, this would be the classical method because, we don't actually see and count the number of individual complaints, but we know the totals. So complaint found to be legitimate, 794, out of the total with the affidavit, which is 7,296. So you're dividing those two numbers. Again, does not matter to me whether you list it in decimal form or fraction form, but if you're going to use the fraction, then make sure it's reduced.
Just right now for 26C, would you do 297 over 794?
Probability, legitimate complaint with affidavit results in suspension with the officer. 297 out of 794. Yes.
Do we have to round to the thousands for that one?
So what we had put in the notes was that generally decimals we round to 3 decimal places unless they've told us otherwise. So yes, unless they tell you otherwise, your probabilities should go to 3 decimal places. Others?
You can go for 40.
40. Let's see. 40 is back to the heads, tails assignment. So this table. And it asked which of the assignments of probabilities should be used if the coin is known to be fair. So if the coin is fair, then theoretically heads and tails should be equally likely. So then that means that we're looking for the assignment where each of the outcomes has the same probability. So we'd be looking at this guy, because it's the only one where they're all the same and it actually makes sense. Because D doesn't, you've got a negative, right? Probability can't be negative. That's impossible.
For 38 for the graph, are we supposed to do a scatter plot for that one?
Number 30.
Or 38, sorry.
38. Yes. Yep. So just like the one I did with the train in the notes yesterday, and then it tells you in the directions which one goes on the horizontal axis. So that guy's your X, and then the proportion is your Y. Anything else?